Hello, welcome to my channel. We will be doing question number 17 today. Okay, this is pretty easy. The sum of two terms of geometric progression. You remember the geometric progression for part A first. Okay, for geometric progression, we know that nth term is equal to first term, which I call A or A1, whatever, r power n minus 1. So the sum of the first two terms. So you can see that first term is A only. So because when n is equal to 1, 1 minus 1 is 0. Okay. And the second term is going to be A into R. When n is 2, 2 minus 1 is 1. Right? So the sum of first two terms, so A1 plus A2, which is same as A plus AR, right? So this is given to be as 10. Okay. And the third term, A3, that's going to be A and r power 3 minus 1 is 2, and that is given as 9. Okay, we need to find the possible values for the common ratio. Okay, common ratio and the first term. So we need to find A and R. Okay, so you can see from the first expression, if I take A common, it's going to be 1 plus R, and this is equal to 10. And if I divide this equation with the second equation, which is divided by AR square divided by 9, right? So A cancel out. And if I do the cross multiplication, it's going to be 10R square equal 9 times 1 plus R. Okay, no problem. So 10R square and plus 9R will go to the negative left side, it becomes minus 9R minus 9 equals 0. Okay, now we have a quadratic equation. We can solve it and find the value of R. Okay, so let me use the quadratic formula. R equals minus B plus minus under the root B square minus 4 into A into C. C is minus 9, so what I will do 9 and I put plus here. Okay, and divided by 2A means 2 times 10. Okay, and when this thing is solved, we get two answers. One is 1.5 and the other is minus 0.6. Okay, so we have two values of R. Okay, now I will use which one I should use. Uh, let's say this expression. This is easier. Okay, so I will use this expression, find the value of A. You can see A is equal to 9 over R square. Okay, so if R is equal to 1.5, then A is equal to 9 over 1.5 square. Okay, and this comes out to be with my calculator. So divided by 1.5 square, and this comes out to be 4. Okay, and if R is equal to minus 0.6, A would be equal to 9 over minus 0.6 and its square. Okay, so let me do this part. It is 0.6 square and is 25. Okay, so basically we are talking about two series or two progressions. So first term is 4. Okay, then next term would be 6 if I multiply because common ratio is 1.5 with this term in this one, right? So the next term will be 6 and the next term will be 9 and so on. Or the other possibility is that first term is 25 and you multiply with minus 0.6. So next term will be minus 9, 15 Again, you multiply with the minus 0.6, and next one will be 9, and so on. So you can see, if I add first two terms, it's going to be 10, and the third term is 9. If I add the first two terms, it's going to be 10, and the third term is 9. So these are the two possibilities for this particular problem. Okay, okay. Now find the sum to infinity of the convergent progression. Okay, this is part 2. I have done part 1 basically here. Okay, now sum to infinity of a convergent progression. You see, this one, it is not converging. The value and every next value is going to be increasing, right? But this one is converging. This is becoming smaller and smaller and smaller. So I can find the sum of this one, not this one. Okay, so how can I find the sum to infinity? It is a over 1 minus r. Remember? Okay, so a for this one is 25 over 1 minus, and r in this case was minus 0.6. So it will be plus 0.6. Okay, and when you calculate this number 25 over 1 here, it's going to be 15 and 5 over 8. Okay, interesting. Now we will do part B, but I need some room. So let me clean up some. Okay. Yeah. So where is this thing? Okay, now let's do part B. Okay, okay, let me get a bit more. Okay, part B. If an arithmetic progression, you remember the arithmetic progression, the nth term is given by A, you can say A1 plus n minus 1 into D, right? Okay, so in an arithmetic progression, first term is minus 10 and fourth term is 14. Okay, so the first term, we can also call it A, this is given as minus 10. Okay, and fourth, okay, he's calling it U1, but this I'm calling it A1. So this is, don't be confused. Okay, U1 is first term, A1 is first term. It's the same thing. Okay, now fourth term, okay, using this expression is going to be A, which is minus 10 plus 4 minus 1, 3 into D, and this is given as 14. Okay, so from these two informations, I want to calculate the value of D. Okay, so you can see 3D is equal to 14 plus 10. This is 24. So D is 24 over 3. This is 8. Okay. Uh, so we know that in this progression, the first term was minus 10 and the common difference is 8. Okay. How can I use this information? Remember, sum of n terms in an arithmetic progression is given by n by 2 and 2a plus n minus 1 into d, right? Okay, so we need to find the sum from u100 till u200. Okay, so let's see, how can I do this thing? Remember, if I find the sum of first 200, sorry, not a, but s, the sum of first 200 terms. Okay, so how will I do this? 200 over 2 is 100 and 2a. So this is going to be minus 20 plus 200 minus 1 is 199 times d, which is 8. Okay, if I do all this calculation, yes, it comes out to be 157 200. Big number, right? Okay. And if I try to find the sum of first 100, okay, no, not 100, but 99. Okay. Why 99? Because after 99, from the hundredth, I need to count them. Okay. What I'm trying to say that, let's say first time is A1 and then A2 and then it goes up to A99 and then next one is A100 and then A101 and it goes up to A200, right? So what I'm going to do, I will add all of them first and find S200. Then I will subtract the value from A1 to A99. Sorry, actually here. Okay. Uh, this here. Okay. So if I had just found A2 S200, right? And now I would find S99. So that is going to be 99 over 2 and 2 times minus 10 to the minus 20 plus 99 minus 1 is 98 times 8, the common difference. And this will give me a number of 37,880, right? So now I'm ready to find this sum. So let me do use U now, not instead of A. I could have used A as well. Anyway, so U100 plus U101 plus up to U200, that is going to be 157,200 minus 37,818. So the answer would be 119 and 382. Okay. I hope it's clear, all the steps and all the logic behind the steps is clear. Thank you very much for watching. See you in the next video.